All right, we are going to be working on 7.8, and this is going to take us through the different parts of linear programming, and I will be doing all the even problems. You guys are in charge of the odd, but the instructions for number 2 are up at the top, so look over the instructions. We're going to be given a graph, and we want to maximize the profit. Now, this problem has most of the work done for us. Somebody has found a business, and they've given us a graph, and the shaded part is where our business can operate. That's the feasible region. And they've even nicely made a profit equation for us. So that equation, when we plug X and Y into it, is how much money we will be making in our business. Now, if you remember from yesterday, the corners of the shaded part, or the feasible region, are where we can make the most profit or the least profit. The origin is the least. Now, we don't want to make less money, we want to make more money. So we're going to focus on the points that are not the origin, these 3. Okay, so we're going to split them into X's and Y's. This top point is on the Y-axis. So that 25 you see there, that belongs to the Y because it's on the Y-axis. There is 0 for the X. X's need to move left and right. This point is 15 on the X. It's 15 to the right. And then if you look at how tall it is, that's one way of looking at Y is how tall is it? How high is it? So it's at a 20. And this guy down here is on the X-axis, so he's at 25. And he doesn't have any height, so he's at 0. All right, we've got the 3 corners where we might make the most money. So we're going to take the X and Y from a single point and plug it in. 7.5, and we're going to plug in that 0 for X plus, and this should be a 9, but I'm writing a 25 because I jumped ahead and started writing the number I'm plugging in. So there's the 9, and here's what I'm plugging in. I'm plugging in the 25. Okay, the 7.5 part, that's a 0. And then the 9 times the 25, remember you're timesing those numbers that are plugging in. That's 225. And when we add it all up, we get more 225. So that's how much money that vertex or corner will make right there at our business. So now it's time to look at the next point. 15 will plug in for X. So there's that 7.5, there's the 15. And then we are going to plug in a 20. For the Y, so here's our 9, and the 20 plugs in instead of the Y, we see the 20. And now it's a good time to grab a calculator because 7.5 times 15, I already swapped some numbers on the top equation, might as well, better safe than sorry, might as well type it in and see what I get. So 7.5 times 15 ends up being 112.5, and we're going to add that on to 9 times 20, which is 180, that one's not bad. 9 times 2 is 18, with a 0, 180. So we're going to add those together. We get 292.5. Because profit is usually in money, you can add a 0 to make it 50 cents, if that makes more sense. Last point, we're going to plug in X for X and Y for Y. So there's the 25, that's the X, and the 0 is the Y. Once again to the calculator. 187.5 plus nothing is still 187.5. And now we can compare how much money each of the vertices or corners will make. And we obviously want to make the most money. We want a successful business. So we want that one. Okay, now we're going to go back up and make sure we have everything the instructions are asking for. So we want the vertex that makes the most money, and that's the corner. So 15 and 20, that's the corner that makes money. And we're going to add on the profit, 292 and 50 cents. And that's how much money will actually be made at that corner. And that's where we will maximize the profit on our business. All right, we're on to number 4. And in number 4, we have a story problem about a seafood restaurant. Josefa has opened a seafood restaurant. Not my favorite, but some people like seafood, so we support them. The instructions for this say we're going to write the constraints. Those are the limits. So those are the equations that limit our business. And we're going to solve them for y, because ultimately we want to be able to graph it. So that's why we need y to be alone. So going back to our seafood restaurant, I would rather have a burger stand, but that's okay. So Josefa has 50 large plates, and she can put 1 lobster and 1 Alaskan king crab, or 1, on each plate. And we notice that the lobsters are x, and the Alaskan king crabs are y. So there's 1 x of those and 1 y of those. And all of these are talking about plates. So these are all talking about the same thing. That means they get to go into an equation together. So we have 1 of those x lobsters and 1 of those y crabs. And we cannot go over 50 plates. That's why I'm putting in inequality. But you could put an equal sign if that makes the math easier. But technically it is that we need to be at 50 plates or smaller than 50 plates. So 50 plates is the most we can have. Okay, next up, we've got a fish tank for these guys because they need to be fresh. Actually, seafood's okay if it's fresh. So we have 240 gallons of water. We don't have any more than that. And the lobsters need 3 gallons each, 3x. And the crabs need 12 gallons each because those are big. Those are massive things. So we have 12x and 12y and 3x, and they are all talking about gallons of water, so they all go into an equation together. And the lobsters and the crabs have to have less water than what's in the tank, so that's 240. So now we have our 2 limiting equations, and you just scan the story problem for those. Next up, we're going to solve for y, because that's also in the instructions. So we're going to remove the x part, leave y alone. Those are not like terms, so they will not combine. They're just going to sit there and be 50 minus 1x. 1y is technically just y, so we're technically done, but if you would like to divide it out, you can see what it looks like. And 50 divided by 1 is just 50. And this is going to be a slope. Remember that x has the slope. So 1 over 1 with an x, that's actually going to be the slope. And now it's ready to be graphed. So to graph it, you need that y to be alone. We're going to do the same thing over here. Here's the y. We're going to remove everybody around it. The y itself doesn't move. So take the entire x portion. That includes the number that's attached to x. You're going to subtract it away. And we're going to be left with 12 and y. And on the other side, we still have that inequality. It can be an equal sign, but it's more correct to have a less than. And again, those aren't like terms, so they're just 240 and a minus 3x. The 12 is multiplying with the y, so we're going to do the opposite. We're going to divide it, and it divides into everything. Okay, so we have just y. And then 240 divided by 12, that's 20. And then we have minus. Now this isn't going to divide nicely, but we don't want a decimal. We actually want a fraction. So we can leave it like that if you want to. That will work. Or you can reduce that fraction, because 3 will divide into the top and the bottom. So you can reduce it to 1/4, and do make sure it's negative. That means you'll be going down on the 1 or down on the 3, depending on which slope you're looking at. All right, we are now on to the final problem, number 6. And a graph has been made for us. And if you look back at number 4, it's actually the graph we made back there, or the lines we made back there. That's the graph. It starts at 50, and then it goes down 1 over 1. And if you look at the other constraint, these are the limits on the business. It should start at 20, and it should go down 1 over 4. So if we look down here, the other line starts at 20, and then it's going to go down 1, and then it's going to go over 4. So this is actually linked to number 4. And it doesn't matter that the numbers aren't 1 and 4 on the axes. That's okay as long as they are the same units on both axes. So we're now looking at profit. So with the seafood restaurant that Josefa's got, Josefa wants it to be profitable. She wants to make money off of it. So we have $3.50 for the Maine lobsters. And if you remember, those were the X's back on number 4. And $7 for these Alaskan king crabs. Those are the Y's. So they make lots of money. But if you remember, they also used a lot of water. So now we're going to put this together in a profit equation. And there's no total that we're equaling quite yet, other than it's just going to be the profit, because it's going to be different depending on how we run our business. So the business itself will determine what the profit is. So we don't know, and that's what we're going to find out in number 6. So we're going to find the vertices. Those are the corners. And remember, this origin corner, we're kind of going to ignore that one because that's where we make the least amount. But these other 3 corners of the shaded region, so think of the shaded region as a shape. These other corners, that's where what we're going to write down over here. So we're going to write down the X and the Y. And that top one has 20 on the Y, but then it doesn't go left and right. So on the X, it's just a 0. Okay, this corner is 40 on the X because it's 40 to the right. And then its height, or how tall it is 10. Y is how tall it is. And then this bottom guy is 50 on the X, and it doesn't have a height. It's just at 0. All right, and now we're going to run these through the profit equation. 0 goes in for X for this first one, and we're going to reuse the profit equation on each of these vertices or corners. 20 plugs in for Y, like that. And then that part's 0. 7 times 20 is 140, so if you added those together, it would still be 140. So that's how much money that corner makes. Next corner, we're going to take the 3.5 and plug in 40 for X and 10 for Y. And this is where we grab the calculator if we're a little uncertain about what 3.5 times 40 is. And then we will add it to 7 times 10. That part's going to be 70. And we'll get a final answer. And you can do that entire thing in the calculator all at once if you want. When you add them both together, you end up with 210. Last corner. 50 goes in for X. And then we're going to put nothing in for Y, or 0. 0 is the number that represents nothing. So the 7 times the 0, that part's going to be 0, and then we'll add it to 3.5 times 50. That number happens to be 175. So now we're going to compare and see where we make the most money. Looks like it's 210. That's where we make the most money. That's the vertex that gets us the money. So the actual profit is $210. That's how much we can make. And then number of lobsters, that's the X. The number of crabs, that's the Y. So I'm going to go back to the vertex because X and Y mean something. And so to make the most money, we want 40 lobsters and 10 crabs. Because remember, those things mean something. And that is how Josefa can make the most profit from her business.